Hello, welcome everyone. In this video, I'm going to cover a couple of rules about derivatives. One of them is called the power rule of derivative. The other one is called the derivative of a constant times a function. How to take the derivative of that particular scenario. So the first one is that if we have a basic polynomial like this, nth degree polynomial, the way we take the derivative, we take the polynomial from exponent and bring it to the front, make it a coefficient, so this n becomes a multiplier, so n times x to the n minus 1, and we subtract 1 from the polynomial degree. So I'm gonna write it down and go ahead and just so we have work it out. We have this d over dx of x to the nth power. So we bring the degree of the polynomial to the front, so it becomes a coefficient n times x to the n minus 1. So this would be your derivative, would be n x to the n minus 1. Okay, when you take the derivative of a simple polynomial function like this one, this is what it becomes. Okay, the n, which is the degree of the polynomial, becomes a coefficient, and then we have x raised to the n minus 1. We subtract 1 from the degree of the polynomial in exponent. And the second one is when we take the derivative of a constant times a function, it becomes, the constant comes out of the derivative, so we have d over c times d over dx of f of x. Okay, and then you can take the derivative of this right here. All right, let's go ahead and work out a couple of problems here. So we have 3x squared. So if we look at this one, we actually have a constant multiplying with a variable x to the second power. So we have a polynomial of second degree and we have a constant multiplying with it. So if we want to take the derivative of this, so we have d over dx of 3x squared. And we take the 3 out, and d over dx, I'm going to put a just dot to show it's multiplying, and inside we have x squared. Okay, now when we take the derivative of this, basically we can apply the power rule right here. So we have a second degree polynomial, and we bring that 2 to the front just like here, and then times x to the 2 minus 1. So it's pretty simple. So 3 times 2 comes to the front, x to the 2 minus 1, and you have 6x. 2 minus 1 is just x to the 1, so it's 6x right here. This is your final answer. Let's go ahead and do this one. We have 5x to the 4th. So we want to take the derivative of this function, d over dx of 5x to the 4th. So first thing I'm going to do is that this constant is multiplying with f of x. So this is your constant, and this is your 4th degree polynomial function, or the variable, I'm sorry. So we're going to take this 5 out of there, d over dx, and we're just going to leave that x to the 4th inside the variable. And then we go ahead and take the derivative of that using the power rule. So this the degree of the polynomial becomes a coefficient, so which is 4 times x to the 4 minus 1. Okay, we just subtract 1 from the polynomial, and then we have 5 times 4 is 20, and this is x to the 4 minus 1 is 3. So this is your final answer when you take the derivative of this function using the power rule of the derivatives. Let's go to the next example. We have 2x to the 4th and the whole thing raised to the second power. So here we have to apply this property of exponents, where we have m to the nth power and raised to the, let's say, p power. So we could write it as m raised to the n times p. We can multiply the exponents here. So So this is what we have situation right here. So first I'm going to go ahead and simplify it a little bit. So we have 2 to the second power times x to the fourth to the second power. So I basically separated the terms inside. Since they're multiplying, we can separate them. Not in addition and subtraction, but we can separate them in multiplication and division. So that's important to remember. So this 2 to the second is just 4. And let's see, we have x to the fourth raised to the second power. So we can apply this particular, exponent rule to this. So x to the fourth raised to the second power is basically x to the fourth times 2. So you have 4x to the 8th power. Now we can take the derivative of this. So we have d over dx of 4x to the 8th power. And now what we learned that we can take this constant out of the derivative. So we can put 4 in front times d over dx of x to the 8th power. And we go ahead and take the derivative of inside. So 8x to the 8 minus 1. So it becomes 32 when you multiply these two, x to the 7th power. So this is your answer to this particular problem. Let's do this one. We have 2 times x to the 3rd power. So we want to take the derivative of that. So d over dx of 2x to the 3rd power. First we pull out the constant from the expression and we make it coefficient. So d over dx of x cubed. And the second is we take the derivative of the inside. So this is 3x to the 3 minus 1. So we have 2 times 3 is 6, x to the 2nd power. So this is your final answer when you take the derivative of this. And this one, we have a cube root of x. So I'm going to simplify it first. I'm going to write it as x to the 1/3 or x to the 3rd. Okay. X to the 1/3 power. So now it's simplified. Now we can go ahead and take the derivative d over dx of x to the 1/3. Okay, and we bring the 1/3, which is the n. So 1/3 to the front times not the derivative. We already are taking the derivative. And this is x to the 1/3 minus 1. So we have 1/3 times, when you simplify this 1/3 minus 1, it becomes negative 2/3 when you combine these terms or subtract 1 from 1/3. So we have 1/3 x to the negative 2/3. Now here we use the exponents again. When we have a negative exponent, we can change its position. We can bring it in, if it's a numerator, we bring it in denominator to make it positive. So we have these two correct answers. For this problem. Okay, so that's how we do it. So we applied two rules here. One was the power rule. The other one was the rule where a constant is multiplying with a function. We take the constant out of the derivative and we take the derivative of the function and then just multiply it at the end. And that would be your final solution. So hopefully this helps.